Okay. Okay, welcome to my YouTube channel. And in this video, which is lesson 2, we're going to look at the structure of the vernier calipers. Okay, the vernier calipers, let me just get my pointer. The vernier calipers has the following points, or the following parts. Okay, the first parts we have is the internal jaws. This is what you call the internal jaws. This one and this one here up at the upper part here, that's what we call the internal jaws. Then the external jaws here, that's what we call the external jaws. Then you have the vernier scale. The vernier scale, which is just here, this box here, that's what we call a vernier scale. And then we have the main scale here. This to my reading, which is showing here to my line. This to my lines here is what you call a main scale. Then the stem is a whole thing. This whole thing. That's what we call the stem. Okay, now look at the parts. The main scale. The main scale, which is this one here. What is it? The main scale is on the stem and is fixed. When they say that it's on the main scale and it's fixed, what they mean is that it's not movable. It's just on one position. It is marked in centimeters, which means the reading or the SI units for the main scale on the stem is what? Centimeters here, in centimeters. Then we go to the vernier scale. Okay, vernier scale. The vernier scale, which is just simply the vernier scale is movable and it slides on the main scale. When they say this, is simply said this part here, the main scale, it can actually move from this direction and backwards again at the same time. That's what it can do when they say the vernier scale is movable and slides on the main scale. That's what they mean. Then it is marked in millimeters. Its SI unit is in what? In millimeters. It has an accuracy of up to 1/10 of a millimeter. That's the accuracy it has. The vernier scale, this one here, this boxing. Then the internal jaws, they measure the internal diameter of an object inside of a cylinder, inside of the ball, the diameter of the ball, and all those things. Then we have the external jaws. The external jaws, they measure the external diameter of an object. It's just simply the opposite of the internal jaws. Okay, now we go to precautions. So what are the precautions you need to consider before using the vernier calipers? Okay, so what you need to do is you need to zero the instruments before taking a reading. When they say zero the instrument before taking a reading, they simply mean, the best example I can say it is when you want to use a stopwatch. If you want to use the stopwatch, you have to reset your clock at 0. You have to start it from 0. If you start it from another time, maybe after 2 minutes have passed, and after 5 minutes have passed, and you want to use the same stopwatch to record the time it has taken for one person to finish 100 or 50 miles, that reading will be wrong. Why? You haven't started the clock from 0. So here same applies to the vernier calipers. You have to start it from 0. That's what this sentence means when they say zero the instrument before taking a reading. And the next one is clean the instrument so that it is free from dust particles. The vernier calipers is very sensitive, so that even dust particles can be measured. Okay, we go to how to read the vernier calipers. Okay, number 1, you need to find the value on the main scale that appears just before the 0 of the vernier scale in centimeters. Okay, I'll explain this here better. What they say that you need to get, what we're saying that find the value of find the value on the main scale that appears just before the 0 of the vernier scale in centimeters. Okay, so we have a vernier scale. Why? The vernier scale starts from here, 0, up to here, where is 10. So they say before the 0 of the vernier scale. So if you want to take the reading, you go here on the 0, then you get the figure that's before this 0 right here. The figure which will be there is what? 4, 4.1, 4.2, 4.3, 4.4, 4.5. So our reading, our main scale reading, it will be what? 4.5. So now I go to number 2. What you need to do, the second one, you need to find the value of the line on the vernier scale that coincides. Okay, we have this word here. You need to understand the meaning of this word here. This word simply means that the line which is in how can I best explain this word, which is in direct, or it's direct straight line with the arrow which is on the bottom part there. Okay, what they mean is that, have you seen this 0 here, right? On top here, is there any line? No, it has no line. Have you seen this one here, this line here on top? Does it have any line on top? It doesn't have. So when they said it coincides, it simply means that this line which is on the vernier scale here, it must be in a straight line with another line which is on top here. For example, if you look at 5 here, 5 millimeters here, it is in straight line with what? 5. This is what we call what? Cosides. The lines are forming the scale on the bottom and the scale which is on the top. They are forming what? A straight line. That's what we mean when they say what? Coincides with a line on the main scale and the main scale. So the third one is add the main scale reading and the vernier scale reading. Okay. Okay, so here the third one, they said add the main scale reading and the vernier scale reading. What they mean, after getting the vernier scale reading, which is 5, the reason why they are multiplying if is 0.01 is because that you need to convert this vernier scale reading into what? Into centimeters. If you look at back at the previous from saying, I just said that the vernier scale is always measured in what? In millimeters. So for you to convert millimeters into centimeters, you need to do what? You need to multiply that number by 0.01 to get what? That number in what? In centimeters. To convert millimeters into centimeters, you simply multiply that number by 0.01 centimeters. Where has this 5 come from? The 5 has come from because here on the bottom part, which is the vernier scale, why? The number which is coinciding with a number with another number on top of the scale here is 5. 5 is the only number which has formed what? A straight line between these two scales. That's where this 5 is coming from. I repeat, the 5 here is forming a straight line between the scale which is on the bottom and the scale which is on the top. They are forming what? A straight line. Hence, we get that number which is on the bottom part as our what? Our vernier scale reading. Then you multiply that number by 0.01. Why? Because we need to convert that number into what? Centimeters. When you multiply that 5 by 0.01, what you have done is that you have converted that number into what? 0.5 centimeters. And what do you do next here? We go to a point 3, which says what? Add the main scale reading and the vernier scale reading, which is what we have done here. The 5.4.5, it has come from I've gotten this figure. I've gotten this figure How did you get this figure? You got it by saying, okay, what is the number before the 0 mark? The number before the 0 mark, that's our main scale reading, which was what? 4.5. The 5, the number on the vernier scale, which is the down part scale, which forms a line, a straight line, with the number which is on top of the scale. That's our 5. Then we multiply it by 0.01 to get what? 0.05 centimeters. You have converted. Then you just add those two figures. Then that is what? Your reading. That's how you read the calipers. Okay, we'll go to example number 2. Okay. Okay, example number 2 states the reading shown in the diagram of a vernier calipers. State the reading shown in the diagram of vernier calipers. Okay. So here, how do you find the main scale reading? You simply go on the 0 mark of a vernier scale, on the 0 mark. Then you check the number. What's the number before the 0 mark is what? 0.1. Hence, that's what our main scale reading. 0.1, 0. He don't get confused. This is not a 10. This is not a 10. Remember, any numbers after the point are no a single number. So this is 0.0. This is 0.10. It's not a 10, eh? So don't get confused here. That's how this 0.1 has come from. How we went to the 0 mark on the vernier calipers, then we checked the number which is there before it, which is what? 0.1. Then how do you find the vernier scale reading? Simply check the vernier scale itself here. The vernier scale is this one, starting from 0 up to 10. So now we check within this, between 0 and 10, which number or which line is making a straight line, or is making a straight line between the lines on the bottom and the lines on top. Because if you look at these other lines, they're not what? They're not meeting up, or they're not forming what? Straight lines. So you need to get a number that is forming what? A straight line. So if you look at the vernier scale here, the number which is forming a straight line is what? We have 0 here, we have 1, we have 2, then we have 3. 3 is the one forming what? A straight line. That's where this 3 has come from. Then this 0.01, the reason why we're multiplying this is because we want to convert this 3 into what? Centimeters. Because remember, earlier on in this video, I said that the vernier scale is always in what? In millimeters. So after converting that into centimeters, you simply add the two values, which will give you what? 0.13 centimeters. Okay, thank you for watching Physics Explained. Please don't forget to like, subscribe, and share to others. And look out for lesson number 3, which is the micrometer screw gauge. Thank you.